So looking at two more examples, both of these have radicands that are not just a variable. There's some extra stuff underneath this square root on the left and this cube root on the right. So we still want to square in the left example or cube both sides in the right example in order to get rid of that radical. But there might be some other things going on before or after. So taking a look at 3, in order to isolate the radical, in other words, get it by itself, we still need to get rid of this minus 5. So we can add 5 to both sides, and then eventually we'll divide by 2. I'll do that as 2 separate steps and show all the work here. 3 plus 5 will be 8. And then to get rid of this times 2, the opposite of times 2 is divide by 2. So dividing both sides by 2 will isolate the radical. So that's very much like the previous example. 8 divided by 2 is 4. In order to get rid of the radical, like the first couple examples, we need to square both sides. What's different about this problem from the previous one is squaring both sides won't be it. There is still stuff here by the x. So when I get rid of the radical, when those cancel off, I still have a 2x plus 4. In the previous example, squaring completed the problem. Once we had finished squaring, x was by itself. But now what I'm left with is a 2-step algebra 1 equation. Because I had this linear setup under the radical, I still have some work to do. X is not by itself yet. So we'd have to subtract 4 in order to get rid of that. 16, take away 4 will be 12. And then last but not least, another division by 2. Dividing both sides by 2 will give us 6. So notice there's quite a few steps here. We had an addition and a division outside of the radical, and then we also had a subtraction and a division once we got rid of the radical. So there's quite a bit going on in this problem. For that reason, it's really important to go back and double check your work. If x equals 6, like we're claiming, then I should be able to go back to the original equation, substitute that value in, and double check. 2 times 6 plus 4 minus 5. I'm making the claim that this equals 3. Well, 2 times 6, that's 12, plus 4 is a 16. The square root of 16 is 4. 2 times 4 is 8. And 8 minus 5 does equal 3. So please go back and double check your work. A calculator can make this very quick, especially if your mental math skills are a bit rusty. But this value that you get, this x equals 6, had 5 different steps where something could have gone wrong. So please go back, double check your work. Highly, highly encouraged. Example 4, now we have a cube root instead of a square root. This one isn't quite as bad because we don't have stuff on the outside of the radical. There's no plus 4 on the outside or a times 6 or anything crazy like that. But we do need to do some work after taking the cube root. So to get rid of the cube root, we cube both sides. Again, the cube and the cube root, those will cancel. So I'm left with just the 2x plus 54. And that's going to equal 4 cubed, or 4 times 4 times 4, which is 64. So like the previous example, now I have another linear equation here. 2x plus 54 equals 64. Solving that is 2 steps. There's an addition, it's a subtraction, minus 54. From both sides, we'll get rid of the plus 54. We'll get 2x equals 10. And to get rid of that 2, the inverse of times 2 is divide by 2. So x is going to be 5. We do want to double check that 5. Again, double checking is simply substitution. If I'm telling you x equals 5, I can prove that by taking the 5 and substituting it back in. 2 times 5 is 10. 10 plus 54 is 64. The cube root of 64 is 4. Hey, 4 does equal 4. So this works out exactly the way that I'm claiming it does. Go back, double check your work. Absolutely, absolutely go back and double check your work. At this point, we've looked at a handful of equations. Some of them required quite a few steps. Others, just 3. Some of those entry-level ones were just 1 or 2. Go try some Math Excel problems, see where you get stuck, see where your questions are. We're going to start building these up a little bit more. Eventually, we'll have some quadratics that come out of these, not just linear equations. So they are going to step up in difficulty. Go through and see how you're doing at this point. Raise a hand if you need some help, if you have a question, you aren't sure where a number comes from, and just let me know how you're doing.